Dear friends, we are into the next data structure model, that is queues. So here we will be seeing how queues are organized as a data structure and how its operations are performed, and also see how they are implemented both in static and dynamic representation. There's a saying, many of us find it difficult to stay in a queue, normal queue. We all want to jump the queue or be what is called a priority queue. All right, let's see how it's done. So as a definition, we can say that it's an ordered list where insertions are permitted at one end of the list and deletions are permitted at the other end of the list. So by rule, the end where insertions are done is called the rear of the queue, and the end where deletions are performed is called the front of the queue. So as we said, items enter at one position called the rear and they exit from the front of the queue. So let's see how the two operations are performed. So if you look at some characteristics of the queue, of course, it's a linear data item. It can be static or dynamic as implemented. Static using an array, dynamic using a linked list representation. Items are organized here based on the first in, first out principle. That means the item that comes in first moves out first. Operations possible, we can insert an item or entry of an item, or we can delete an item, and we can traverse the list of the queue. So let's see how the operations can be performed or implemented using both. So these queues are also will be studied in topics like simulation and other papers, queuing theory. So we have entry of item, exit of item. Entry is marked at the point where rear is marked, and an exit takes place always from the position marked by front. So when we implement, let's say, using a static representation using an array, we use an array, okay, let's say of size max having n elements. Max is the maximum size of the array. And initially we keep front and rear point to 0. So which means it's the initial state of the queue and it is empty. Every time there is an entry of item, we enter the item to the position marked by rear, then we increment rear. Rear moves to the next. And similarly, enter next, and the rear keeps moving. And the moment rear reaches max, equal to max, that means the queue is full. And reversely, when there is a deletion of item, we know the deletion takes place from the front of the queue. So when I delete first, an item deleted is item pointed by front. Having deleted, I move to the next location of the queue. Of course, here it is progressive, so increment the front and keep on moving. And anytime front is equal to rear, that means the queue is empty. So if rear is here and front 2 reaches there and an item is deleted, that queue means is empty. So this is how an implementation can be done using a static representation of a queue. When we come into a dynamic representation, let's imagine this as a dynamic representation. We have nodes with values, of course, and they are pointed. Look at the diagram. I think we have just represented in the reverse order. So this is the first item inserted. So initially rear and front are pointing to null to say that it is an empty list. Then we have a first item inserted, rear points here and front points here. For every node inserted, right, every node inserted, the rear moves, the front always remains on the first node of the list. Now, if I want to have one more entry, let's say a new item getting inserted here. So let's say a new item comes here, nothing but I need my rear to move here. So it is nothing but, if you look at as a linked list, a new node getting inserted, at the beginning of the list. So move the rare here and points. It's easy. Since we know this node, I can always connect and move the pointer back to the new node. But when I want to delete an item, it's always the first item being deleted. It's easy. I know this node. So if I delete this particular node, I move my front pointer forward to the next node. So when will my queue in a dynamic implementation become full? It's only when my memory is, let's say, overflow. Otherwise, we can keep on adding nodes. So this is one way of implementing using the dynamic representation. We will be also studying in this line different types of queues. I would like to just explain here. So we have what is called a priority queue. That means items that come do not enter according to the position of the queue, but they may go based on a priority. So higher priority items gets to a higher place, to a more superior place in the queue. That is one way of representing. That is called a priority queue. Another point that you need to take care of, a common question that is asked is, what is a drawback of a normal queue? Now, if you look here, let's imagine there are items in the queue. Let's imagine there is an item here, there's an item here, there's an item here, there's an item here, there's an item. So there are items here, and now according to if the rare would be here. Now let us imagine I delete a particular item. That means I delete this item, which means my friend is here. Having done that, I also add an item, one more item. So when I add an item, my rare now becomes here. I have inserted, and this is rare. Now, what happens when I have inserted this item, or after this, what I get is my rare is equal to max. That means my queue will now report full. But is it really full? No. If you look here, this item is free because we have deleted this. This remains free. But queue reports as full because my rare has reached max. So this is a drawback of a linear normal queue, which can be overcome by what is called a circular queue. So a common question that is asked, what is a circular queue? So circular queue is nothing but we connect this in a reverse, in a circular fashion. We connect both together, rare and friend connect together, then items move in circular fashion. So when I know when there is no item here, I can always proceed and move to the next. So my question is, explain a normal queue. What is the drawback? How is it overcome? Or reversely, how is circular queue made to overcome the defect of a normal queue? Thank you.